Hey guys, we are back. We've got kind of a variation of what we were just doing. Now, permutations matter what position you're in. Like everything we were doing was like first place, second place, third place, or president, vice president, secretary, treasurer. So when you were picking people, it mattered where they went because were they the president? Were they the vice president? Did the horse come in first place, second place, or third place? Now, very similar ideas, combinations. Now, the difference on a combination is it doesn't matter what order you're in. You're just grabbing a group of people. So that's a little different mathematical thing, and you can see we use the letter C for combination. So permutations obviously uses the P, combinations use the letter C. Now, I think this will be an easy one for you to understand. So let's say that you have 7 friends, and after school, they're all saying, hey, can you give me a ride home? Well, you don't have room in your car for 7 people, but you have room for four passengers. Okay, so you're driving, you got somebody in the front seat and 3 people you could fit in the back seat. So you got room for 4 passengers, so 7 friends. Now, obviously, people are going to argue, I want shotgun and all that stuff, but really, it doesn't matter where they sit. You're going to put 4 people in. See, that's the difference. It doesn't matter where they sit. The order doesn't matter. You're just letting 4 people into your car. But you have 7 friends, so how many different combinations of those 7 friends could fit in your car? And again, the order doesn't matter. So what we do, now what's nice, but a lot of this, it looks similar. So we got 7 people, and we can put them in groups of 4. So again, we're grouping them in 4. There's not an order. It doesn't matter who's number 1, number 2, number 3, or number 4. It's just you're taking a group of 4 friends and putting them in your car. Okay, so here's the difference. So the top is the same, 7 factorial. Okay, the top is still the number of things you have. Okay, and then the bottom starts the same, 7 minus 4 factorial. Okay, but here's the difference, guys. There's less, because the order doesn't really matter, there's less answers, there's less combinations. So the extra is actually the other factorial, 4. So the other number is a factorial in the bottom. So you have the top is that big number, the bottom is the 2 numbers subtracted with a factorial, the bottom is that 4 factorial. So we got 7 factorial, 7 minus 4, which is 3 factorial, and then we obviously have 4 factorial. Okay. Now this is going to be a little more complicated, okay? And we've got, hopefully you can see, okay, let me move this over a little because it looks like the light was in the way. Okay, so you got 7 factorial, 3 factorial, 4 factorial. Okay, now we're going to look at different options here. Guys, whatever one is bigger, you want to start with that. So that 4 factorial is down here, but still, okay, 7 factorial we know is 7, 6, 5. Okay, and then 4 factorial. Now, again, we've got a 3 factorial and a 4 factorial on the bottom. I'm going to take whatever one's bigger. That's going to save you some time. So this 4 factorial on the bottom can cancel with that 4 factorial. I don't want to go down to 3 because that's less than 4. I want to cross out the bigger number. 4 is bigger than 3, so I'm going to cross out the 4. Now, here's what's strange then. So this 3 factorial kind of needs to be, that's still going to stay. So 3 factorial is going to stay. So this is a little different than the last one where we just crossed stuff off and we're kind of done. So now we're actually going to multiply 7 times 6 times 5. Okay? So 7, calculator on, 7 times 6 times 5 in the numerator. So 210. 3 times 2 times 1. 3 times 2 is 6. 6 times 1, that's kind of easy. 6. Now, this fraction right here, remember, means divide. So again, this is going to take some math to simplify. So 210 divided by 6, and actually, there's our answer. There's 35 different ways that you could take a group of 4 in your car. Okay? So again, there's 35 different ways. So again, the difference here, again, the 7 factorial and the subtraction was what a permutation had because the order did matter. But when the order doesn't matter, then you have that extra second number as a factorial. Okay? Let's try another one over here, a couple more over here. Okay? So we've got 9 things taken, okay, in 2 different ways. So I'm grabbing 2 at a time. I don't know, I'm trying to think. Maybe you have 9 sets of clothes, okay, and you're going to take 2 at a time, a shirt and a pants, okay? How many different ways? And again, the order really doesn't matter, just grabbing stuff. Okay, I don't know. We'll do some story problems next time, but I'm trying to think of a story problem for this one. But again, 9 things taken at 2 at a time. The order doesn't matter. So again, 9 factorial over 9 minus 2 factorial and 2 factorial. See that? Okay. So 9 factorial. 9 minus 2 is 7 factorial, 2 factorial. Okay. So again, we've got 9, 8, 7 factorial. Again, because I've hit my bigger number. Remember, I want to go to the bigger number, not to the smaller number. So 7 factorial and 2 factorials on the bottom. So because I got to the 7, I'm going to cross out the 7. So I'm left at 2 is left. 2 factorial, that's easy. 2 times 1, right? 2 factorials, 2 times 1. Now 9 times 8, I mean, this is one we can do in our head. 9 times 8 is 72. 2 times 1 is 2. Now I can do this one in my head because it's pretty small. 72 divided by 2 is 36. Boom. So there's 36 different ways that you could pick out the clothes that you could put on, okay? So 36 different combinations. If you had 9 things, taken 2 at a time. Okay, last one. Okay, we have 15 things being taken 6 at a time. So let's say 15 people on the basketball team, 6 can fit in the van. Okay, you're going to take the van over to the game. Okay, how many, and again, it doesn't matter where they sit, even though people might want to sit in shotgun or whatever. So we're taking 15 people in a group of 6. So how many different combinations? Okay, let's do the math again. So 15 factorial. Okay, then 15 minus 6 factorial and 6 factorial. Okay, let's move sideways here. So we got 15 factorial. 15 minus 6 is 9 factorial. 6 factorial. Okay, this one's going to be a little bit harder here. So we got 15, 4. Whoop. Getting ahead of myself. Slow down. Okay, 15, 14, 13, 12, 11, 10. Okay, now I'm going to hit my big, again, I got 9 and 6, and I'm going to hit 9 first. So I'm going to go 9 factorial. Okay, so the 9 factorial on the bottom is going to cross out, but I still have that 6 factorial. Now again, remember, this 6 factorial then now has to be multiplied. So I'm going to do 6, 5, 4, 3, 2, 1. Okay, now these are going to be some big numbers. Okay, use your calculator. Okay, so 15 times 14 times 13 times 12 times 11 times 10. Okay, big old number, 3 million. Okay, so 3,603,603 600. Okay, that's a big number. You have a calculator, no big deal. Okay, now remember, we're still going to be divided by what's on the bottom here, so we're going to need to multiply this one out. So 6 times 5 times 4 times 3 times 2. Again, remember, times by 1 doesn't do anything, so I can just stop at the 2. Okay, 720. So 6 times 5 times 4 times 3 times 2, 720. Okay. Last step, again, top divided by the bottom. Remember, fraction means division. So that 3 million number divided by 720 divided by 720. Okay, 5,005. So 5,005. Boom. There we go. 5,005. That is our answer. Okay? So that's how many different combinations you could get in the van. If you had 15 players and you're putting 6 in a van at a time, that's how many combinations you have. 5,005. Okay? So, just for practice, go ahead and take that one there. So 12 things taken in a group of 7. So you have 12 items taken in a group of 7, okay? There's your answer. Okay, solve that, plug that into the journal, and you're good. Okay, so we'll stop here for this week. Okay, so this is our last one for this week. Next week, we'll actually do combinations with story problems.